20th century physics largely developed around two big theories. There's quantum mechanics, which describes atoms, molecules, and subatomic particles. And then there's Einstein's theory of gravity, which is applied to stars, galaxies, and the universe as a whole. If you try to put the two theories together, you run into problems, mathematical contradictions, because the nonlinear mathematics Einstein used in developing his theory is not well suited for the needs of quantum theory. Now, it doesn't really make sense to have one theory for big objects, stars, galaxies, and the whole universe, and another theory for atoms and subatomic particles, because ultimately, for example, a star is made out of atoms, electrons, protons, and neutrons. So whatever are the laws that determine what individual electrons, protons, and neutrons do, when applied in the large to many, many particles, will tell you the behavior of a star. So there's a need in physics to reconcile quantum theory that we use for the small things with Einstein's theory of gravity that we use for the large things. Physicists stumbled upon string theory 40 years ago in bits and pieces, and it's a trail we've followed ever since then. It's an incredibly deep and rich theory, and the pieces we've discovered have been wonderful. But we don't understand what's really behind it. It's quite different from general relativity, Einstein's theory of gravity. Einstein had the ideas behind his theory before he developed the theory. So by the time he wrote his equations in 1915, just about 1 century ago this month, he had a pretty clear picture of what it was all about. String theory, I think, in some ways, is a much more vast and far-flung enterprise, and certainly no one has had the complete conception for it. And even after 40 years, we only understand bits and pieces. So my dream would be to understand what's the new kind of geometry that string theory embodies.